video, we're going to focus on simplifying logarithmic expressions. You can also do these same processes with solving with logarithms. One thing you can do is you can condense logarithms back by using the properties below in the red, blue, and purple. The other process you can is convert a logarithm to an exponential equation. And the third type is to use your inverse or one-to-one properties. All of these have already been taught to you before. I just wanted to review with you different processes that we have learned. So now let's go through and do some examples. So the first step we'll work on is just using our properties of condensing. Okay. So what we have is two logarithms on problem 1, and they are both of the same base. They are both base 4. So the operation in between them is a plus symbol. So if you want to combine them back together, you can condense them by multiplication. So x equals a logarithm base 4, and now what multiplies together is the 2 and the 32. Now we'll continue simplifying. So 2 times 32 is 64. Now you have a few ways to go about trying to simplify this. One way is you could try to rewrite it into exponential form, or you could use maybe your inverse property, and that's the way I'm going to go. So I'm going to go ahead and say the log base 4, and then I'm going to rewrite 64 as 4 raised to the 3rd power. Now the inverse property says that if you have a logarithm of base 4, an exponential base 4, then your final answer is this power. So your answer is x equals 3. All right, here's our second problem. We have a logarithm base 2, another logarithm base 2, and the operation in between them is subtraction, so you can combine them back together into one logarithm by division. So we say x equals logarithm base 2. Now we're going to divide 32 and 4. All right. So we've condensed them back into one logarithm. Now we're going to take 32 and divide it by 4, and we get 8. All right. Now let's see if we can simplify some more. So just like the previous problem, we used the inverse property. We could use exponential, convert it to an exponential. We're going to leave it as it is. And we're going to change 8 to an exponential, so we can use the inverse. So 8 is the same thing as 2 times 2 times 2, so 2 to the 3rd. Now here's our inverse property. We have a logarithm base 2 and exponential base 2, so our final answer then is x equals 3. All right, question number 3. We want to condense or simplify. In this case, it already is condensed. So now we want to think about, how could we maybe take this power here and throw it down in front? So now we have a logarithm base 5 and then 1 over 5. All right. Now let's work on the logarithm. I can rewrite 1/5 as an exponential of base 5, because 1/5 is the same thing as 5 to the negative 1 power. Now, these two pieces are inverses of each other, so that answer is going to give you negative 1. Now, we still have this 3 out in front. So we have the 3 out in front, so now we multiply. 3 times negative 1 is negative 3. All right. Question 4. Very similar to the one that we just did. We have this 2 power, so I'm going to bring it down in front. And I'm going to focus on the logarithm. So log base 3 of 81. Now let's see if we can use our inverse power. Say what exponential base 3 raised to what power would give you 81? Okay, hopefully you're there now and you figured that out. 3 raised to the 4th power is 81. So these two are inverses of each other. we're going to be left with just the number 4. We still have the multiplier of 2 in front. We multiply 2 times 4, and we get 8. All right, question 5. We have 2 logarithms. They're both subtraction. So we can condense them back together by division. So x equals a logarithm base 2 of 384 over 6. So we take 384 and we divide it by 6. And we get 64. Now let's see if we can raise that to a base 2 gives us 64. All right, so take a logarithm base 2. We're going to change that 64 to an exponential of base 2. So 2 to what power would give you 64? Well, 2 to the 6th power is 64. These are inverses of each other. So our final answer is just going to be that power. So x equals 6. All right, I'm going to scroll down. This next problem got a little bit long. So we have now 3 logarithms. And we want to find out what x would be. All right, so they're all going to be base 12. So we're going to hopefully be able to condense them back together. Before we condense, let's think about the multipliers in front. We have a 1/6, a 1/4, and a 1/2. So let's bring those back up as powers. So it looks like this. We have x equals logarithm base 12 of 729 raised to the 1/6 minus logarithm base 12 of 16, raising it to the 1/4, plus logarithm base 12 of 64, raising it to the 1/2. Now, if you remember fractional exponents, they can be rewritten as radicals. So that's what we're going to do next. We're going to simplify. So I'm going to take the radical of 729. Now look at my denominator. My denominator is a 6. So I'm going to have a 6th root there. Head over to the next logarithm. Logarithm base 12. Radical of 16. Now, our denominator is 4, so we're going to take the 4th root of that. Plus logarithm of base 12. Radical of 64. And now my denominator is 2, so my index will be 2. All right, so now we have to take the radicals and reduce those. So we're looking for numbers raised to the 6th power. So what raised to the 6th power would give you 729? So just start off with maybe 2 to the 6th. Nope, that doesn't work, that's 64. So let's try 3 to the 6th. That's 729 is 3 to the 6th. That's a little messy there. 3 to the 6th. All right. So when we reduce this entire piece, they undo each other. The 6th root of 3 to the 6th just gives us 3. So now we have logarithm of base 12 of 3. All right. Let's head to the next logarithm and simplify its radical. So we have a 4th power, or 4th root. So we need something raised to the 4th power underneath. That will give us 16. Well, 2 times 2 times 2 times 2 is 16. So again, to simplify this, 4th root, 4th power, they undo each other, and you're just left with a 2. So minus logarithm base 12 of 2. All right, last one to simplify for a logarithm, logarithm base 12. Now we have an index of 2. We're looking for something raised to the 2nd power. Well, 8 times 8 is 64. So index and power match up, so this whole thing becomes an 8. Log base 12 of 8. All right, so now we have 3 logarithms in pretty reduced form. Now we want to condense them back into 1 logarithm. Be careful that they have the same base, 12, 12, and 12. So the operation in between here is subtraction. So to combine them back together, we're going to divide. The operation in between here is plus, so we're going to multiply. So x equals logarithm base 12 of, here's our 3, divided by 2. And now look at the plus 8. Now where does that plus 8 go? If I want to change it, I can put it over to here. That goes up in the numerator, because plus means multiplication. All right, so now let's simplify within the parentheses. So 3 times 8 is 24, and now we're going to divide it by 2. 24 divided by 2 is 12. All right, now I'm going to throw this as an exponential term. The reason why is this is a logarithm of base 12, an exponential base 12. They are inverses of each other to the final answer of 1. This one is a little more challenging. It is a little more work, but hopefully we